So hi everyone, myself Saloni, and we'll start this lecture with a brief introduction about myself. So I completed my MTech in computer science from IISc Bangalore in 2019, and then I worked with a biomedical AI startup called Inference, and I recently left it to teach you guys. And I have a total experience of 6+ years in ML and 4+ years of industry experience. And me, along with Deval, have co-founded the Depth of ML, and I'm also going to be your one of the instructors. So today, I actually wanted to motivate you guys on why linear algebra is important in machine learning. But before that, I want to build some fundamental base so that you understand what I'm talking about. So in today's class, we will first look at what is a vector. Then I'll differentiate between a vector and a point and what is a matrix. And these three will be enough to understand what I want to talk about in the role of linear algebra in machine learning. Okay. So you might feel this lecture is very fundamental, very basic, but I'm still going to go ahead with it. You might feel that it's going slow, but I actually want you to have a very strong foundation. And then once we move to advanced concepts like solving linear system of equations or SVD, this should not hinder in your understanding. Okay. So let's get started. So first of all, what is a vector? Can anybody tell me what's a vector? And where have you studied before? It's already there on the slide, but what do you understand, your understanding of vector? If you can unmute yourself and let me know. Guys, anyone? You must have studied this as in physics, in 12th class physics, right?
Somewhat similar to this only. It's a quantity that has a direction.
And a magnitude, right? So you might have seen like distance vectors, right? In physics specifically, I think till 12th, we see vectors in physics only. You might have seen a force vector, right? So how we define it as there is some vector, which is like a one-sided arrow. It has some direction, right? Direction. And also it has some magnitude. And these two things are good enough to define a vector, right? So you might have seen vectors like this or vectors like this, right? And you might have also seen the vectors in a 2D space. For example, I can draw a vector like this. This is a very valid vector. And usually in physics, we represent them like this. But in linear algebra, we'll just denote them via like a normal, not even this. We'll just use a single small letter alphabet. That will be it, right? So you might have seen other vectors, or you can basically, vectors have a direction and a magnitude, and that's it. And you can start the vector from anywhere. That's what you might have seen till now. But there is a difference when we come to vectors in linear algebra. So in linear algebra, vectors are always origin rooted. And when I say origin rooted, so first of all, what is origin? So in a 2D space, which is like this, where there are two coordinates. This is coordinate 1, which is x-axis, and this is coordinate 2, which is y-axis. We have 2 points representing the origin, which is like 0, 0, like 2 coordinates representing the origin. Okay, so in linear algebra, you will always see vectors which are rooted at the origin. So if I have to draw a vector, for example, I have to do 1 and 1 or 2. So it means that x-axis coordinate is 1. So this is 1. And y-axis coordinate is 2. Right? So this is how we draw a vector. So this is my vector. V. Right? Is it clear?
Yes, ma'am.
Cool. Let's do another vector. I am focusing so much on this, like how you draw vectors, is because this is important if we move forward. So I'll do just one more. So this is vector 2, 3. Actually, let me do -2 and 3. So when I do -2 and 3, I will go -2 in the direction of x. And then I'll go 3 in the direction of y. Right? And this is my vector. Let me use this another. This is my vector u. Okay. These are vectors in linear algebra, and the thing that we have to remember is they are always rooted at the origin in linear algebra. Though in physics they can be anywhere. They can start from anywhere. They have no concept that they have to start from the origin itself. Okay. Also, in computer science, when we talk about vectors, they are also ordered. We also visualize them, or we also assume them to be an ordered list. What I mean by an ordered list, suppose that I am trying to make vectors for these three people. Okay. And there are two values that I want to denote. So this is height. This can be my coordinate axis 1. So this is my first coordinate axis 1, and this is my coordinate axis 2. Coordinate axis 2. Okay. So what I will do is, so instead of doing x or y, I will represent them like this. So my x is now height and my y is my weight. Okay. Now if I have to draw this guy over here, which is say A, so the height of this person is, for example, 2, and the weight is around 5. Okay, so it will be somewhere here. So this vector is basically corresponding to this person A. I'm representing this person A in a vector form on a 2D plane where each coordinate is denoting some feature. And that's what we call feature or some property of that particular person. And this can be anything. Okay, so here, for example, I'm taking person and its attributes as height and weight. It can be anything. Now, and when I say ordered list, what it means is I cannot do it like I have to create a vector. So first of all, let's write vector here corresponding to it. So the vector will look like this, right? So the first axis is height, the second axis is weight. I cannot write it like this, 5, 2, because that will be incorrect. Right? So we can't do this, and that's what I mean that it's an ordered list. That you have to put these values in an order, and then only you will be able to get the correct vector. Now let's do the second person. So say this person B. So this person has a height of 3 and this person has a weight of 8. Okay, so it will be somewhere like this. And similarly, we can have that green person as well. So this person is C. Actually, this person is B. So what I have done is here that I have represented these three people in form of a vector. And I have taken these two features as the coordinate axes. Is this clear? Let me do this. So it will be somewhat like this. Okay. So this is my C vector. So in computer science, these vectors are usually considered an ordered list. So this is clear to us. Okay. So I'm going very basic on this. So I'll draw these vectors that I already drew for you. 2, 5. So should I actually come to this slide and done that? Okay, so this is my person A, this is my person B, and this is my person C. Right? So 3, 6 is here, 3, 9, 6. and I am rooting it at the origin. So this is my person B. And C is 6 and 8. So this is something like this. Right? So this is how we represent whatever data we have in computer science in form of an ordered list. And we can't switch the order of this because it has to be, so every axis corresponds to some feature or some property or some attribute of the quantity that we are trying to represent or the entity we are trying to represent. Moving on. Let's talk about the dimensions of the vector. Okay, so I've given this vector V here. Can anybody tell me what is the dimension of this vector and why? You can unmute yourself and let me know what is the dimension of this vector.
It is a two-dimensional vector
Why
because
is that?
it has two coordinates there in the Cartesian plane.
Correct. So everybody understood this? I know this is very basic, but I just want everybody is clear on this, that what is a two-dimensional vector. Everybody clear?
Yes.
Cool. So this is actually a vector that belongs to R2, like two-dimensional plane. So we have planes like R1 to Rn, right? And I will just take one more slide. And we'll just erase this. And this one, and then erase it here. So we have something called as Cartesian planes or real coordinate planes, which are like this. Okay, so if I'm talking about R1, I have only one coordinate axis. Coordinate axis. Okay. When I'm talking about R2, I have two coordinate axes. And dot 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 dot. I also have n coordinate axis. Okay. So this is a vector in R2 because it has two coordinate axes. So if I have to draw it, I can easily draw it in 2 dimensions. So the standard coordinate axes are x and y. So if I have to draw this vector, how will I draw this? So how does this vector tell me that what is happening? So it tells me that in direction x, you have to go 2. And then in direction y, you have to go 5 steps, right? And whatever point you're reaching is your vector. And this is rooted from origin. Correct? So this is my vector 2, 5. Now, what is the dimension of this vector? Anybody can unmute and tell me?
1 dimension.
1 dimension, because
There's only
there's only one axis, which is the x-axis that we are using it to represent, right? So if I have to represent this vector, this will be just this much, right? This is my this vector, and suppose this vector is u. U belongs to R1, correct? Now let's talk about this vector. This vector is W. And now you should be able to tell me very easily what is the dimension of W. Please unmute yourself. 3, correct? So somebody said 3. Raidu said that this is a 3-dimensional vector. So the dimension of this is 3. Everybody clear why it's a 3-dimensional vector? Because we can represent it using 3 dimensions, right? So here I'll actually switch to a very interesting tool called GeoGebra. And here you will be able to visualize these vectors that we have. Okay. So usually 3D vectors we can still visualize, but it becomes difficult when we go to higher dimensions, but 3D we can still work with. Okay. So some people usually find it difficult to visualize a 3D vector. So I'll just make that easier for you. And so suppose that my vector is 1, 0, 0. Okay. So this is the vector. If you can see the pointer, this is X direction, this is Y direction, and this is Z direction. So it's telling me that in X direction, you have to go one step. So here is the vector for 1, 0, 0, right? Suppose now my vector has also a non-zero coordinate in y axis, right? So if you visualize it like this is X axis and this is Y axis. So this is 1 on X and then 1 on Y. So you have a vector over here. Now, if I have to take this vector to 3D, like with 3 dimensions, where Z dimension is also non-zero, what will happen to this vector?
Will go up a little bit.
It will go up a little bit, right? So let me show this, right? So this is the third, this is a vector with X and Y is 1, 1. And how do I visualize this? That this is equal to, I will just keep it like this. And you can see that in Z axis also, this is coming to be equal to 1. Right? So now I had to draw a vector which was 1, 2, 3. Let's see how it looks like in 3D plane. I'll just turn off other vectors. And this is my 3D vector. Okay. So I have 1 in X dimension. I have 2 in Y. And I also have T in Z dimension. I will share this link so you can play around with this. Do play around with this 3D visualization and try to understand these vectors more. Okay. And I think this is very basic. A lot of you must already be knowing this, but still. Fine. So this is what a dimension 3 vector looks like. Moving forward, can anybody tell me the dimension of this vector?
2.
3.
2. Sorry, 3, 3, 3.
Okay. Who said 2?
Ma'am, by mistake, I said 2. It is actually 3 because in Z axis, we are going 0 point ahead.
Cool. So this is a mistake that a lot of students make. Okay. So that's why I put it here, because I know a lot of people will look at it and assume that, oh, this is a 2-dimensional vector. So it's not 2. The dimension is 3. And a lot of students actually make mistake here. So here we have a coordinate. Though the value for this coordinate is only 0, doesn't mean that your dimension will reduce. You will still use 3 coordinates, 3 coordinate axes to represent this vector. Okay. So this vector A belongs to R3 again. So this is clear, right? Till here we have visualized vectors. We have seen what is a 1D vector, R1 vector, a 2D, R2 vector, a 3D, R3 vector. And we also saw what is like a general vector, Rn vector. Now let's move on to a very basic thing. So I want to differentiate between a point and a vector. Okay. So what is a point? So point, for example, I have this 2 cross 2, 2, right? This is a point that I have. So what is the difference between this 2, 2 and 2 and 2? It's already written on the slide, but if I have to draw this point here, right? So this point is just a place in the space. Okay. It has no notion of magnitude. No notion of magnitude. And also no notion of direction. So a lot of students actually get confused between a point and a vector. So this is a very basic difference, that a point will not have any direction and it'll just be like a point. I'll represent it using a point. But a vector on the other side will have, and also this will be like a fixed position. Okay, so 2, 2 will always be here. But suppose I have to draw 2, 2, right? I can, in general, draw 2, 2 anywhere. Okay, I will go 2 direction here. I will go 2 direction here. And this is my 2, 2 vector. Okay. But in linear algebra, he did say that it is always rooted at origin. So this will be my 2, 2 vector. But in general, there is no such criteria that vector has to be from a fixed position. But in general, linear algebra, we just take it to be rooted at origin. Fine. So that's a difference. So a point is just like a fixed place in the space. A vector is basically something that is starting from a point and going in that direction with a definite magnitude. So a point does not have any notion of magnitude or direction. But vectors, they don't have a fixed position, though in linear algebra, they start from from origin, and they also have a direction and a magnitude. Okay, this is also very basic, right? How do I add two vectors? This is also very important in linear algebra when we go forward, like how to add two vectors. So can anybody tell me what will be the vector? So say this is A vector and this is B vector. C is equals to A plus B. What will be the value of C?
5.
5, right? And geometrically, if I have to see it, how will I do it? So I will start from the origin. I will move one step forward for A. Then from A, I'll move 4 steps forward for B. Which I should have drawn this in yes. This is my B vector, right? And whatever I'm getting as result, starting from the origin to the point I ended, is my C vector, right? Now, the same notion actually translates in 2D or 3D space as well. So I will first draw these two vectors. So I have 2 and -2. So this is my vector A. Say this is A vector and this is B vector. And I have to do A plus B. Okay. So this is my vector A. And from here, it's telling me that when I'm adding it, I have to move 4 steps forward in the x-axis direction. So from 2, I will move till here, right? So I will move here. And then I will move 3 directions in positive. So I will land up here. So actually, this will not be coming. This will be the right? And if I add it, it will be 2 plus 4 minus 2 plus 3. And this will be 6 and 1. Okay. So this is how we add two vectors, right? There's another interpretation to this, that you draw both these two vectors. So for example, I have drawn already A. I will also draw the B vector. So 4 and then I have P over here. Right? And you can just place this 4 and 3 from this. Right? And you will reach the same point. So this is my B vector. This is also my B vector, right? So I did nothing. I just took this vector and I put it at this end of where A was ending. And I got the resulting vector, which is here, which is C. Fine. Now let's do in 3D. So again, we'll move to our 3D visualization tool. Here. So this is my vector 2 minus 2, 3. Let's verify this. So this is 2 in x-axis. This is 2 in x-axis, minus 2 in y-axis. And if I have to talk about the z-axis, I will just do this. And it's coming out to be 3, correct? So this is the correct vector. And I want to add this vector 4, 3, 1 to this. Okay, so let's visualize 4, 2, 3 as well. 4, 3, 1 as well. So I have 4 in x-axis. I have 3 in y-axis. I think this will become more clear, right? And then I have 1 in the, I do this. I have 1 in the z-axis, right? I want to add these two vectors. So here I can just do this operation. Let me first go here, okay? So what will happen if I take the vector and just place it over there? Let's see. So what I have to do is I am in, let's do this together. I'm here, okay? I'm at this vector, which is B. I'm in x-axis, I'm at 2. It's telling me to go forward 4 steps, right? So actually I should have, but it'll go 4 steps ahead. So in x-axis, it will go till here, 6, somewhere here it will come. Then in y-axis also, I have to do 3. I am at 3, and then I have to move forward. I'm actually at -2, and I have to move forward with 3. Right? So I will move somewhere from -3 to +1. So I will be somewhere here, right? We'll come here. And then in z direction, I have to do from 3, I have to move to, I have to add 1, and I'll come at 4th coordinate. So the resulting vector will be 6, 1, 4. I'm not able to use my pen over this, but let's just visualize how this vector will come. So this will come like this in this direction, right? So this is going a little outside the graph. I can actually fix this, but this is trivial, right? So it's on x-axis, it's going till 5, till 6. In y-axis, it's going till 1. And then in z-axis, we can visualize very easily that it is coming out to be 4. Right? So this is how we add vector in a 3D plane, 2 vectors in a 3D plane. I actually also wanted to show what is like a point. Let's look at the point as well. So I have plotted this point A. Okay. So this is just one point. And a vector will be like, if I have to instead plot a vector, it will be just like starting from the origin and going till here. Fine. So coming back. So this is nothing but 6, 1, and 4. And we have seen how to geometrically add these vectors as well. Right? In general, whatever vector I have, I will actually make this not with x. I will give it something generic. So suppose I have a n-dimensional vector. So I have a1, a2, and an. Okay, so this is my vector A, which belongs to R of n. And I'm adding another vector to it, which is B1, which is also of the same dimension. You can't add vectors which are not of the same dimension. So we'll just Bn. Okay. And B also belongs to Rn. So we get a C vector, which is simply just A1 plus B1, A2 plus B2, and An plus Bn. Okay, this is C vector, which also belongs to Rn. So they should belong to same space, same cardinality space, so that we can add them. Fine. There's another operation that we can do on these vectors, which is scaling. Okay. So I have this vector A. Okay. And I'm saying I want to scale it by a number called 2. So it's just saying that, okay, so you took a step 1, just take those steps twice. So I'll take step 1 and I'll again take a step of same magnitude, which is and in the same direction. So this is my 2A. So this will become my 2A. So you can actually add vectors and also you can scale them. So this is my vector. This is my vector A. Fine. This is easy to do in 2D as well. So you have a vector 2 minus 2, which is here. All it's telling you is you took this step here. You take similar magnitude ka step over here as well. So this is this vector from here to here is my 2 of A. And this is again A. And this vector, this yellow vector is my A. I know these are very simple things, but I just want you to visualize and understand how this happens. Again, let's move to the GeoGebra, but this is also very clear. So this is a vector here that is 2, minus 2, and 3. And this is, we had already seen, I think, 2, minus 2, and 3, right? So this is my vector. If I scale it by 2, it'll just, the same length, same magnitude will be put twice, and you'll get a 2A vector. This whole thing is a 2A vector. Fine. Now, finally, we are coming to matrix. Okay. So what is a matrix? So this is not exactly the definition of a matrix, and we are not digging into it in this lecture, and we'll dig deeper when we go forward. But just to give a brief introduction, matrix is nothing but it's a collection of vectors. Okay. And these vectors can be of two types. So they can either be row vectors or the column vectors. So when I say column vector, it means this. Okay. This is column vector. And when I say row vector, it means that the values that are put in here are just lying down, and this is also called row vector. Okay. So this is nothing but you will have, say, V1, V2, and you club them together, and this is called a matrix. So this was very fundamental, very basic, something that you might have seen in your BTech, in your elementary school.